In this video, I'm going to show you how to monitor plant flow data in real time using MQTT, InfluxDB time series database, Grafana Visualisation platform, Schneider IIoT Gateway, and HiveMQ Cloud as the centralized MQTT broker. And for demonstration, I'm going to use this Schneider IIoT Gateway to collect tank level telemetry data simulated by this potentiometer on this legacy controller via Modbus TCP. I'll then publish the telemetry data as MQTT messages to a centralized HiveMQ Cloud MQTT broker, which will forward that data to an InfluxDB time series database running on my Raspberry Pi here. I'll then visualize the information on the InfluxDB database using Grafana Visualisation platform, which will also install on this Raspberry Pi. So the reality is that in most factories today, the majority of production equipment still use legacy communication protocols, such as Modbus in our case. So for us to be able to collect data from this controller for real-time monitoring on the Grafana Visualisation platform, we're going to use a Schneider IoT Gateway to act as a protocol translator, reading data via Modbus protocol on one end and converting it into an IoT protocol on the other end, which is MQTT in our case. And then before we visualize the data, we'll need to store it on a time series database. And for that, we're going to use InfluxDB. Now, both our time series database and visualization platform need to be hosted somewhere. It could be on the cloud or on-premise. However, in this demo, we're going to use a Raspberry Pi as our server for hosting InfluxDB and Grafana Visualisation platform. Now, how do we program the IoT Gateway to perform the Modbus TCP protocol conversion and publishing of MQTT data? The simplest way for us is to use Node-RED, which is a low-code drag and drop platform. Next, we're going to need a centralized MQTT broker for receiving MQTT messages from our IoT Gateway and forwarding them to our Raspberry Pi, acting as the server. And this is where HiveMQ Cloud MQTT broker comes in. Now, here's the thing. Our MQTT messages are not going to be automatically sent for InfluxDB storage from our HiveMQ Cloud broker. What we need is a bridge for catching these MQTT messages and persisting them to the database. And for that, we're going to use Telegraph, which is an InfluxDB server agent that is capable of subscribing to receive MQTT messages from the HiveMQ Cloud MQTT broker as input and persisting them to the InfluxDB database as its output. Now, the first thing that we need to do is to make sure that our broker is up and running. And to do that, I need to access my HiveMQ Cloud portal. So I'll go to the HiveMQ website here, and then under Cloud, I will select HiveMQ Cloud. And when I do that, I'm redirected to this page. So I'll scroll down here. So here you'll see that there's a free basic version which allows us to connect up to 100 clients. So I'll select sign up now. And then I'll be taken to the HiveMQ Cloud portal homepage. And here I'll enter my login information because I already have an account. If you do not have an account, you can go ahead and sign up by entering your email and password. So when you sign up for the first time, you'll need to follow the simple steps of setting up your cluster. Once your cluster is set up, you can configure or change your MQTT client credentials under Access Management, as you will see in a minute. Okay, so with those few simple steps, I have my MQTT broker up and running. Now I'll need to copy my MQTT broker details that I'll use for publishing MQTT data from my Schneider IIoT Gateway. So I'll select Manage Cluster. And here under Manage Cluster, I'll copy the host name or broker URL address. And here you'll notice that our MQTT broker is using TLS encryption at port 8883. Okay, and then I'll select Access Management. So this is where you configure or update your MQTT client credentials. For example, I can remove the username and password that I created when setting up this cluster, and then recreate it. and then I'll copy the username and password to be used later on in our IoT gateway. Okay, so that's all for our MQTT broker setup on HiveMQ Cloud Portal. Now the next step is to start publishing our plant flow telemetry data from the Schneider IoT Gateway. And the best part about our IoT Gateway is that it comes pre-installed with Node-RED. So all we have to do is to access its interface via a web browser. So I'll open a new tab on my browser, and then I'll type in the IP address of my IoT gateway, which is 192.168.0.128 at port 1880 for Node-RED. Okay, I've already put together a Node-RED flow for reading the tank level value simulated by the potentiometer on our legacy controller via Modbus TCP. So let's go through each of the nodes. Let's begin with our inject node. Here you'll notice that we're reading data every 5 seconds. Next, I've got a function block for preparing our Modbus message. So if I double click into the node, you will see here that I'm specifying the function code for reading holding register, which is 3, and my controller Modbus ID, which is 110, and the Modbus register that holds our potentiometer value. And lastly, because our Modbus word is two 16-bit registers, we're going to set quantity to 2. And then we move on to our next node, which is the node responsible for sending the Modbus requests to our controller. So this is where we configure our Modbus communication parameters. So as you can see here, we're using Modbus TCP, and we have my legacy controller IP address and the Modbus port number, which is 502. Now, as mentioned earlier, the response from our Modbus controller consists of two 16-bit integer values. So we need to convert that to a float value. So for that, we're using this function block. So here you can see the few lines of JavaScript code that perform the conversion. Okay, so before we publish our tank level value as MQTT messages to our HiveMQ Cloud MQTT broker, let us deploy this to see if we're getting the right data. So I'll click on deploy. Okay, I'll go to the debug window, and then I'll clear it first. So there you can see we're reading a value of 77.89 after every 5 seconds. So I'll turn down my potentiometer, and there you can see we're now reading a value of 58.6. Okay, now that we're getting the right data from our controller, we can now publish the tank level value as MQTT messages to our broker. Now, since this data will ultimately be consumed by InfluxDB, we need to first understand how InfluxDB consumes this data so that we can structure it accordingly. Now, while InfluxDB is capable of handling data in JSON format and primitive types such as float, they've got their own textual format called the line protocol, which is specified as measurement, tagset, space, value. So in this demo, we're going to use the InfluxDB textual format. And in our case, the text will be tank level, location equals to plant A, space, value equals to 58.6. So what this means is that we have to concatenate our tank level value to this string format and publish it to our MQTT broker. So back to my Node-RED platform, I'll add a function block for creating an InfluxDB textual format. And then inside this function block, I'll copy and paste this code which is for converting our payload to InfluxDB textual format. And then I'll check to see if that is a success. So as you can see, we now have our influx format. So now we can go ahead and publish this to our HiveMQ broker. And to do that, I'll drag the MQTT publish node. And then here I'll add a new broker. And then I'll go back to my HiveMQ Cloud portal and copy the host name of my broker, paste it here, set my port to 8883, enable SSL, and then under security here, I'll put my MQTT client username and password as set on the portal. And then I'll click on add, and then I'll publish this to a topic called plant sensors. And then I'll click on done, and then I'll go ahead and deploy. Okay, so we should be publishing to our HiveMQ Cloud MQTT broker, but to test that we are indeed publishing, I'll open up my mqtt.fx MQTT client, which is already connected to my broker. And then here I'll subscribe to the topic plant sensors. So as you can see, we are indeed receiving our MQTT messages. Okay, now that we are publishing our telemetry data to our MQTT broker, the next step is to set up our InfluxDB time series database to store this data. Now to install InfluxDB on my Raspberry Pi, I'll need to open up my Raspberry Pi terminal. So I'm using PuTTY to access the terminal from my PC. So I'll go ahead and log in. So we're going to be installing our InfluxDB time series database from the official InfluxDB repository. So the first thing that I need to do is to get the InfluxDB repository key using this command. And then I'll add the InfluxDB repository using this command. And then next we make sure that our list of packages is up to date. Okay, now we can go ahead and perform the actual installation of InfluxDB on our Raspberry Pi. Okay, our InfluxDB database has been installed. Now we need to set it so that it starts automatically each time our Raspberry Pi boots up. Okay, when that is done, I'll then go ahead and start my InfluxDB service. Okay, now that our InfluxDB server is running, we can start creating users and databases on it. And to do that, we need to first run the Influx client using the command influx. Okay, so first I need to install the InfluxDB client. And then I'll use the command influx to run the client. Okay, now that we've got our InfluxDB client running, we can go ahead and create a user with admin rights. And to do that, we use this command. So here we're creating a user called admin, and the password is admin password with all the privileges. Okay, so we've successfully created our database user. Now we can go on to create our database for holding our telemetry data. We'll call it Telemetry. Okay, so we've successfully created our database called Telemetry. All that is left for us now is to start storing our MQTT messages in our time series database. Okay, so here I'll exit from our client. And then I'll clear the screen. Okay, now let's go ahead and install Telegraph to start collecting our telemetry data coming from our HiveMQ Cloud broker and store it in our InfluxDB database. To install Telegraph, we first download the package using this command. And then once Telegraph is downloaded, we go on to install it. And then when Telegraph is installed, we go on to enable it to automatically start when our Pi reboots, and then we can go ahead and start Telegraph. Okay, now let's open up the Telegraph config file in order to tell it where to pull our telemetry data from and where to store it. So to do that, we use this command. Okay, so here we're going to leave most of the configurations as default. The only configurations that we want to alter is our Telegraph InfluxDB output plugin to point it to our telemetry database on the local instance of InfluxDB. And we also want to configure our Telegraph MQTT input plugin to point to our HiveMQ MQTT broker. Okay, so I'll scroll down here until I get to our InfluxDB output. So as you can see, this is the section for our output plugins. So here I'm going to uncomment the local host URL at port 8086. And then I'll also uncomment the database and then put the name of my InfluxDB database, which is Telemetry. And then I'll scroll down some more. And then here I'll uncomment the username and set the username as admin. And then I'll also uncomment the password and put admin password, which is the password of my InfluxDB user. Okay, so I've finished configuring my Telegraph output. Now let's go ahead and configure the MQTT input plugin. Okay, so this is our service input plugins. And then here we've got our MQTT consumer plugin. So I'll comment it out. And then I'll go on and comment out the servers here. And then copy my MQTT broker hostname and paste it here. And then I'll change my TCP here to use SSL. And then for topics, I'll put plant sensors. Okay, and then I'll scroll down here, and then under username I'll put my MQTT client username, and then I'll also put my MQTT client password. And then lastly, I'll set the data format to Influx. So this is where if I was using JSON, I would have set it to JSON. Okay, so we need to change our port to 8883. Okay, so that's all that we need to do in our config file. So I'll go ahead and save using Ctrl X to exit, and then choosing to save. Okay, now after configuration, I'll need to reload my Telegraph. So I'll go ahead and do that. Okay, so since we're already publishing MQTT messages to our HiveMQ broker, we should see some telemetry data in our Influx time series database. So let's go ahead and query the database to find out. And to do that, I'll need to first run the InfluxDB client using the influx command. And then I'll select to use the telemetry database. And then I'll select everything under tank level using this query. Okay, so as you can see, we are successfully logging our telemetry data into our InfluxDB time series database. Now the next and final step is to visualize our data using Grafana. So I'll exit out of my InfluxDB client. Okay, now let us go ahead and install Grafana on our Raspberry Pi. So I'll begin by downloading the Grafana package. And then when the download is complete, I'll go ahead and install it using this command. And then next, I'll enable Grafana to automatically run each time my Raspberry Pi boots up. And then after that, I'll start my Grafana server. Okay, so our Grafana has been successfully installed. Now let's go ahead and access it using a web browser. So here I'll put the IP address of my Raspberry Pi. And then I'll put the port number 3000, which is the port at which our Grafana runs. Okay, so which means our Grafana has been successfully installed. Now let's go ahead and log in. The default user is admin and the default password is admin. And then here we're prompted to assign a new password. So I'll go ahead and do that. Okay, so we've successfully logged into our Grafana visualization platform. Now the next thing that I need to do is to add InfluxDB as my data source so that we can start visualizing our plant flow data. And to do that, I'll click on Add Data Source. And then I'll continue by selecting InfluxDB. And then here I'll fill in the URL address of my InfluxDB server. And then I'll enter the database name, the username, and the database user password. And then here we'll select an HTTP method. And then I'll click on Save and Test. Okay, so my data source is working. Now after configuration, I'll continue by creating a new dashboard. And to do that, I'll click on the new dashboard here. And then I'll click on Add an empty panel. And then I'll start to configure my panel using the data of my InfluxDB database. Okay, so here I will select measurement, which is tank level. And then here I'll leave it as value. Group by time interval. And then we can use a linear fill. Order by time ascending. And format it as time series. And then I'll call this panel Plant Telemetry. Then click on Apply. And then you can zoom into your trend. And then here we can choose to see the data for the last 5 minutes or the data for the last 15 minutes. And then here you can set auto refresh to 5 seconds. So now if I turn my potentiometer up, you can see that we're now starting to get a value of 87.5. In conclusion, you could publish MQTT messages as Spark plug payloads for plug and play interoperability using the HiveMQ Spark plug extension, which works on the enterprise or self-hosted HiveMQ broker. I hope you enjoyed this video about real-world MQTT for Industry 4.0. Please check out the HiveMQ YouTube channel for more videos like this.